Hello, geometers and general seekers of truth. Welcome to the video on performing reflections. Not with a mirror per se, but rather with lines and figures and such. And I'm going to work on number 2 right now, which says we want to reflect this polygon over the line x equals -1. And the purpose of this video is just to show you how to do this graphically, and I will post other videos that show you how to do this algebraically for more difficult examples. So the first thing I'm going to graph here is the line of reflection, which is x equals -1. So it's actually a vertical line. A lot of people think that it's a horizontal because they think x is going left and right, but it's actually a vertical line because it's the line where all of the x values is -1. So this point here has an x coordinate of -1, so does this point here, so does this one here, and all of these other points. Actually, there's really no good reason to not have a solid line instead of a dotted one. So this line right here is x equals -1. And remember, the rules of reflection is that however far a point is from the line, that's how far its image will be as well. So let's start with A. So A here is on the left of the line, and if you reflect it, it will be on the right of the line. And so A is 1 unit, 2 units from the red line. Therefore, you just count over 1 unit, 2 units over here. And this is the location of A prime. B is also 1, 2 units from the red line, so we can count 1, 2 units over here, and this will give us B prime. Now C is a little bit more interesting because it's not on the left side, it's on the right side. It's 1 unit away on the right, therefore it's going to be 1 unit away from the red line on the left, and this dot right here is going to be C prime. And now all we really have to do is connect these 3 dots, and this will give us our new triangle, A prime, B prime, and C prime. And that's all there is to it for this example. Again, I think the main things people have a hard time with is figuring out what this line looks like. Once you have the line drawn in, it's easier to identify the object. And I'm just going to shade it in here a little bit more, just so it's clear what's the image and what's the pre-image. So I will end this here, and then we will look at another example where we are reflecting over something a little bit more complicated. Well, I am now going to be reflecting the point A35 over the line x equals 12. And I'm going to try to do this as algebraically as much as I possibly can. I will illustrate it, of course, with a rough sketch so you can see. But for number 5, so using somewhat of a rough sketch, and when I say rough here, it doesn't mean that we can just draw in crooked lines. I'm just not going to label the scale, and I'm not going to worry too much about being drawn to scale, because again, this is a sketch. This is not asking us to graph. Okay, so A35 is 3 over 5 up, and it's approximately here, A35. Okay, and the line that we're reflecting over is x equals 12. So it's a vertical line, so it's somewhere around here, approximately. X equals 12. And we're taking A, and we're flipping it over this line. So you can see that one thing is that the y coordinate, so I'll write it over here. The y coordinate does not change. So whatever A prime is just going to be something 5, because we're flipping it over. So it's going to be somewhere over here, where it's going to be essentially moving along a horizontal path to the other side here. And we just have to figure out what x is. Well, from A to the line of reflection, is exactly 9 units. Okay. Now how do I know that? Well, I know that here this line is x equals 12, so this distance is 12 minus 3, which gives me 9. Okay. So A is 3 units over from the y-axis. X equals 12 is 12 units over, therefore this distance here must be 9. And from that we can conclude that, from A, let's cover the rest of this up here so I get a little bit more space. So from the line of reflection to A prime is also 9 units. Okay. So from here to A prime, wherever that is, that's also 9 units. Okay. And this x value is currently at 12, so the x coordinate of A prime is 12 plus 9, which is 21. So my final answer here is that A prime must have coordinates 21, 5. And again, it's really nice to have this picture to visualize, but the goal is to be able to do this without having to draw a graph every time. Graphing is an important skill. You need to know, you need to be able to do it precisely, but we don't want to rely entirely on graphing. So we'll stop this video here, and I'll start another one where we look at an example of reflecting over a different type of line.